There is a button on the calculator that where if you enter the matrix, I call it the cheat button, but you can actually just hit the inverse button on your calculator and find the inverse of a matrix. But that could get you in trouble if your teacher wants to see the row operations. So be very careful about that and only use it to check your answer. Okay, so let's look at a 3 by 3 example. Now I'm going to duplicate the matrices here to kind of ease the navigation, but in this next example I won't do that. Okay, so here I've give you a 3 by 3 matrix. So I do have a square matrix, so since it's square it could have an inverse. But I'm going to augment that matrix with this time since it's 3 by 3, I'm going to use the 3 by 3 identity. And remember, what I want to do is I want this left side to actually be a 3 by 3 identity matrix when I'm done. So what I want to do first is get a 1 right here, which I already have. So since I already have a 1 right here, I'm going to use that 1 to eliminate the negative 1 in row 2 and the negative 1 in row 3. So all I have to do to eliminate the negative 1 in row 2 is add row 1 to row 2 and put the result in row 2. So that's pretty easy to do. 1 plus negative 1 is 0. Negative 3 plus 4 is 1. 7 plus negative 7 is 0. 1 plus 0 is 1, 0 plus 1 is 1, and 0 plus 0 is 0. And then also to eliminate the negative 1 in row 3, I can do the same operation except I add row 1 to row 3. So 1 plus negative 1 is 0, negative 3 plus 3 is 0, 7 plus negative 6 is 1, 1 plus 0 is 1, 0 plus 0 is 0, and then finally 0 plus 1 is 1. Now I'm just going to copy that matrix down here, and now you want to go to the second row and we want to make this middle element here a 1. So the good news is it's already a 1, and I want to use the 1 now to eliminate the negative 3 that's above it. I don't have to eliminate the number below it because it's already 0. So all I have to do here is multiply row 2 by 3 and add it to row 1. So let's do that. If I take 3 times 0, I get 0 plus 1 is 1. If I take 3 times 1 is 3, add it to negative 3, I get 0. If I take 3 times 0, I get 0 and plus 7 is 7. And then 3 times 1 is 3, and I add it to the 1, I get 4. 3 times 1 here is 3, add it to the 0, I get 3. And then 3 times 0 is 0, add it to 0, I get 0. So now I've got the 1 here and the 0 above it and below it. Now let's copy that matrix down here. I have to get a 1 right here, and so I've got a 1 already, so what I need to do is eliminate this 7. Again, I don't have to eliminate anything in row 2 because it's already a 0, so this one actually is working out rather nice. So let's multiply row 3 by negative 7 and add it to row 1 to get rid of the 7. So if I multiply these zeros by negative 7 and add them to these guys up here, they're not going to change the value. Now if I multiply 1 by negative 7 and add it to 7, I'm going to get negative 7 plus 7, which is 0. If I multiply 1 by negative 7 here, I'm going to get negative 7, and then I add it to 4, and I get negative 3. And then if I multiply 0 times negative 7, I get 0, and add it to 3, and I get 3. And then last, multiply the 1 by negative 7, I get negative 7, and add it to 0, and I get negative 7. And so now, now that I have on this side, I have the 3 by 3 identity matrix on this side, then this side here has to be my inverse of the original matrix. So let's make sure we take it out of the augmented matrix and identify it as such. So the inverse is negative 3, 3, negative 7, 1, 1, 0, 1, 0, 1. And again, if you want to take the original matrix A and multiply it by that inverse to check it, remember their product must be the 3 by 3 identity matrix. Okay, I'm going to leave this one for you to work, so you can pause the video if you want to and try to practice on this one. But let me get you started here. Again, it's a 3 by 3 matrix, so when I augment it with the 3 by 3 identity matrix, I get something that looks like this. And then I, start my steps where I want to get a 1 here, and then I eliminate the 2, and then after I do that, I want this to be a 1, so I make it a 1, and then I use that 1 to eliminate the negative 1 and the 5, and then that gets me to this matrix, and then I want this to be a 1, so I multiply by 2, and that makes that a 1, and then I use row operations along with this 1 to eliminate the 1/2 and the negative 1/2, and then when I'm finished, I have the identity on the left of the augmented line, and on the right I have the inverse. So anyway, you can try that and see if you can do what I did to get the inverse there. And if you struggle, maybe you want to go back to the previous one and go back through the steps again. One of the applications of matrices and their inverses is cryptography, which is the method of encoding and decoding secret messages. And so there's lots of ways that you can encode a message, but one such way is to use a matrix. And let me show you how it works. You got to know how it works in order to be able to do this. So for instance, let's say that the letter A is the first, represents the number 1, the letter B represents the number 2, letter C represents number 3, and so on. And so we're going to let a blank be 0. You could use any number other than 1 through 26 because the numbers 1 through 26 represent your alphabet letters. Okay, now this message, I looked up the alphabet. I wrote the alphabet out and numbered the letters, and S was the 19th letter, E was the 5th letter, C is the 3rd letter, R is the 18th letter, E is the 5th letter, T is the 20th letter, and then for a space I put a 0 here for space, and then C is the 3rd letter, O is the 15th letter, D is the 4th letter, and E is the 5th letter. So that's how I got these numbers. Now, I know I want to use a 2 by 2 encoding matrix. Okay, so I'm going to use this matrix to encode the message. Well, here's the trick. If you're going to use a 2 by 2 encoding message, then you've got to put these numbers in a matrix using only 2 rows. So the easiest way to do that is to make the first pair be your first column, and then you make the second pair be your second column of your message matrix, and then the next pair is your next column, and so on. So 0, 3 comes next, and then 15, 4 would come next, and then 5 would be next, but since there's not a number to go in that column with 5, I'm gonna pretend like there's a 0 here for a space, just so that I have a number to put in that last spot. Okay, now if I was using a 3 by 3 encoding matrix, I would actually do the first column, I would let the first column be 19, 5, 3. In other words, I would put 3 rows in it using the first 3 entries. And then my next column would be 18, 5, 20. And the reason you have to do that is because if you're using a 2 by 2 matrix, then your message matrix has to be 2 rows. It's got to be a 2 by something, because we're going to actually multiply this matrix times the message matrix to scramble the message. And so if you're using a 2 by 2 encoding matrix, this has to be a 2 by something. But if you're using a 3 by 3, then this message matrix has to be a 3 by something matrix. So you have to be aware of that. Now, getting back to this, all I do to encode the message is I take my encoding matrix, which was the matrix 4316, and multiply it by the message matrix. Now I've already shown you how to multiply matrices, so you can do this by hand, or you can plug these into a calculator and multiply them. But this is the new matrix that I get. Now if I wanted to send this message to someone, I would take it out in the same way that I put it in. So I would take it out column by column. So I would have 9124 first, and then the next column is 6621, and the next column is 8025, then 93, 7219, then 25. And so this would be the encoded message that I would send to my counterpart. And then when my partner got this message, the partner would have to know the inverse of this matrix. And so the inverse of this matrix is this. Now, if you don't know the inverse, of course, you have to find it. Now, what would my partner do with this message? Well, my partner would then take this message and rewrite it back into this form, this matrix form. He would put it back into the 2 by 2 matrix, and then he would take the inverse and multiply it by the message matrix, the encoded message matrix, and then guess what happens? When you multiply this row by each column, you're going to actually get the numbers that are the first row of my message matrix, and then when you multiply the second row by each column, the second row is going to give you the second row of my message matrix. And then you can take these out, 19, 5, 3, 18, 5, 20, in that order, 0, 3, 15, 4, 5, 0. And then my partner, once he gets the matrix decoded, now he can read this SECRET space CODE, and he can decode the message. Okay, so it's an interesting application that you can do with matrices and their inverses. Okay, this is the same message, but I'm going to use a 3 by 3 matrix. And remember, 19 was S, 5 was E, 3 was C, RET space CODE space. So notice I had to put it in a 3 by 3 form since I'm using a 3 by 3 encoding matrix. So all I have to do is multiply the encoding matrix times the message matrix, and then I get a new matrix here, which is actually my encoded message. So my message would be 17, 7, 53, 33, negative 10, 51, 12, negative 9, 9, negative 1, 10, 23. Well, then when the person on the other end wants to decode this, they just put it back in this matrix form and multiply it by the inverse of this matrix A. So again, you have to find that inverse, but that's how you would decode the message, is find the inverse of this and then multiply it by this matrix, and it should give you back the message matrix. And then of course, once you have the message matrix back, you can easily determine the solution. Now, down here is a practice problem that I got out of a textbook, and the encoded message is this, and so it was encoded with this message A. So you won't use this matrix. You'll have to find the inverse of this matrix, and then, which I gave you a hint, there's the inverse, and then you'll actually have to put this in a 3 by matrix form, and then multiply this matrix times the new matrix that you get when you put this in matrix form. And then when you get done, you should be able to read the answer, sort of a creative math answer here. Who is Carl Gauss? So you can give that a try. On the next video, I'm going to continue this section with a topic about the matrix properties.